Good day, everyone. So welcome back. Welcome to the intermediate section on our algebra series. Like earlier established in our previous video, we established that algebra has to do with working with unknown numbers. At the previous video, at the beginner's level, we tried to solve some algebraic expression. Now we are the intermediate section. So we are going to be looking at some questions that will also help our understanding on algebra. Now the very first one we are going to solve, we are going to be looking at the first one. So we have the first question. We have 2x minus 7 equal to 9. Now one of the exam tricks I want to reveal in this particular video is when trying to look for the value of x, try to isolate the variable. What do we mean by isolating the variable? When we say isolate the variable, it's we're trying to make x the subject. Now we are going to see that. Now we have 2x minus 7 is equal to 9. The first thing I want to do, I'm going to collect like terms. 2x and 7, or rather in this expression, this is minus 7, they are not like terms. So if I'm to collect my like terms, this will be 2x equal to 9. This is negative 7. If negative 7 crosses over the equal to sign, it becomes plus 7. So we have 2x is equal to 9 plus 7. And 9 plus 7 will give me 16. So at this point, I'm having 2x is equal to 16. Like I said earlier, one of the secrets to solving algebraic expression is trying to isolate the variable. At this point, the variable x, it's not yet isolated. So in order for me to isolate it, when we say isolate, for better understanding, when we say isolate, we are simply saying let the variable stand on its own. When you call the variable, you should be able to call the variable alone. When you call the variable, you should not call it as 2x, you should call it as what? X. Now we have 2x is equal to 16. So for me to further isolate this variable, I am going to divide both sides by the coefficient of x. When we say coefficient of a number, we are simply saying the number that is attached to the variable. And like I said in the previous video, when we say variable talks about letters. So we are going to be dividing both sides by the coefficient of what? X. And the number that is attached to x here is what? 2. So we divide here by 2, we divide here by 2. 2, we cancel 2, so we have that x is equal to 16 divided by 2, which will arrive at 8. So the value of x is equal to 8. Now let's go back to the second question. Now we have a second question. We have 3x equal 21. If you look at this particular expression, it looks like the previous one where we got 2x equals 16. So since we have 3x is equal to 21, we are looking for the value of x. For us to ascertain the value of x, we are going to divide both sides by the coefficient of what? X. And like I said earlier, the coefficient of x is the number attached to x. And the number attached to x here is 3. So we are going to divide both sides by 3. So here divided by 3, here divided by 3. 3 we cancel 3, so we'll have that x is equal to 21 divided by 3 is 7. So see that the value of x is equal to 7. Now let's look at the third example. Let's look at example 3. For example 3, we have 5a minus 2a plus a. Now, before solving this example 3, I want to establish something. Like I said earlier, at Elite Tutors, we don't rush algebra, we take it step by step. Now, I want to establish that there is a difference between like terms and unlike terms. Now, what do I mean by that? Before coming back to solve this our question, if I have 2a and 3a, 2a and 3a, they can be classified as like terms. Why? Because they have the same variable and same power. A term is said to be called like terms when they have the same variable and same power. Very important, the power. And when you say an unlike terms, when they have what? When they have different variables and different power. So what does that mean? Like I said, 2a and 3a, they can be called what? Like terms. But if I have 2a raised to power 2 and I have 3a, we can't call this what? Like terms. It's called unlike terms. Why do we call it unlike terms? Because their powers are different. The power of 2a is 2, while the power of 3a is 1. So we can't classify 2a raised to 2a squared and 3a to be like terms. Now let's move back. Let's go back to solving our question. So when we have 3a minus 2a plus a, we can see that these three terms, they are all what? Like terms. Why? They have the same variable and same power. The power of 5a is 1, the power of 2a is 1, and the power of a is 1. So we can go ahead to what? To add and subtract. Now how do we solve this? So let's simplify. Now 5a, we take this step by step. 5a, we have 5a minus 2a. 5a minus 2a, we have 3a. It's as if you are saying 5 minus 2. 5 minus 2 will give us what? 3, and then you bring your a. So your 3a, don't forget you have a plus sign, plus a. 3a and a, they are like terms. Why? Because they have the same power and they have the same variable. So 3a plus a will give us 4a. Now, I know at this point, most students get confused. Now, how? Now, let me try to explain. When we have 3a plus a, the coefficient of a is 1. What do we mean? The number attached to a is 1. So the same we are saying 3 plus 1 is what? 4. And then you bring your what? A. So when we say 5a minus 2a plus a, our final answer will give us 4a. Now let's look at the fourth illustration. We have 4x plus 3 minus x minus 1. 4x plus 3 minus x minus 1. So when we see this kind of algebraic expression, our ability to collect like terms is very crucial. And at the junior WAEC level, your ability to do that helps you score a higher mark. So please pay attention. Like I earlier established during illustration 3, a term is said to be a like term when it has the same variable and same power, and vice versa for an unlike terms. Now the first thing we want to do, we want to collect our like terms. 4x and 3, they are not like terms. Why? Because they don't have the same word variable. They may have the same power, but they don't have the same variable. So our like terms here, we have 4x. 4x and x, they are what? Like terms. Don't forget a minus sign. 4x minus x. And then you collect the other set of like terms. This is plus 3. You have your plus 3, and this is minus 1 minus 1. Now we've been able to what? Rearrange what this algebraic expression by collection of like terms. Now let's go further to simplify. 4x minus x. Like I said earlier, the coefficient of x is what? 1. So when we say 4x minus x, it's as if we're saying 4 minus 1. So 4x minus x will give us, we're going to arrive at 3x. And here, at this point, we have plus 3 minus 1. Now, most students, they miss out on the signs. So you have to pay attention. When we say plus 3 minus 1, let me explain. Now, when we say plus 3 minus 1, for better understanding, it's you have 3,000 naira and you are owing 1,000 naira. Mr. A has 3,000 naira and he's owing Mr. B 1,000 naira. If he removes 1,000 naira from his 3,000 naira, he's going to be left with only 2,000. And that 2,000 is going to be left to be a positive value. So when we say plus 3 minus 1, plus 3 minus 1, we are going to arrive at plus 2. Now at this point, this will be our final answer. Why is this going to be our final answer? Because this cannot be further simplified. Because they are not like terms. 3x and 2, they are not like terms. Why? They don't have the same variable. They might have the same power, but they don't have the same variable. So 3x plus 2 will arrive at our final answer. And finally, for this intermediate section, we are going to be looking at illustration 5. Illustration 5, we have x plus 2 over 5 equal to 3. Now, how do we solve this particular algebraic expression? Now, I can rewrite this expression to be x plus 2 over 5 is equal to 3 over 1, which is still the same. Like I said in the first video, in our beginner series, 3 and 3 over 1, they mean the same concept. The difference is that 3 has changed what we call form. Because 3 divided by 1, we see arrive at 3. So at this point, it makes it easier for cross multiplying. So we can go ahead to what? To cross what? Multiply. So we'll have that what? X plus 2 all bracket times 1 is equal to 5 times 3. Now at this point, we need to what? Expand our bracket. And how do we expand our bracket? We use what is outside to multiply what is inside the bracket. We're using what is outside the bracket to multiply what is inside. Now let's do that. 1 times x will have what? X. Don't forget plus sign. 1 times 2 will have 2. Equal to 5 times 3. 5 times 3 we are going to arrive at 15. So you can see that this expression has been broken down up to this point, where we have x plus 2 equal 15. Don't forget we are looking for the value of x. And for you to arrive at the value of x, you have to isolate x. So we have x is equal to, you collect item, 15 minus 2. So we have that x is equal to 15 minus 2, we arrive at 13. So the value of x is equal to 13. And to prove that you are correct, if you impute x equal to 13 here in this expression, 13 plus 2 will give us 15. And 15 divided by our denominator, we arrive at 3. Thank you very much.